Hi, Eric.
Hi, Bob.
How are you?
I'm reasonably well, thank you.
Good. Well, reasonably well is all I ever ask for. Thanks for taking the time. Let me introduce us. I'm Robert Wright. This is The Wright Show, available on both streaming video and via audio podcast. You are Dr. Eric Kandel, a famous neuroscientist at Columbia University. You won the Nobel Prize for your work in neuroscience in 2000. And now you've got a new book out called The Disordered Mind, What Unusual Brains Tell Us About Ourselves. You've also written a number of other books for lay people, and some not for lay people, I guess. But this one is. Could we start with you telling us a little bit about the work that you won the Nobel Prize for?
I won the Nobel Prize for analyzing the biological mechanisms of memory storage. I found that different forms of memories involve alterations in how nerve cells communicate with one another. Nerve cells communicate with one another at specialized junctions called synapses, and I found that synapses change with learning. Certain kinds of learning, synapses get stronger, but other kinds of learning, synapses get weaker. So, for example, if I were to tap on his desk, after a while you get bored and you sort of learn to ignore it, and you can see the synaptic connections getting weaker and weaker. On the other hand, if I bang very loud on the table and scare the hell out of both you and me, the synapses get stronger. So different forms of reinforcing stimuli affect synaptic connections differently, and those are the mechanisms for elementary forms of learning and memory.
So they are attentive to novelty, it sounds like, but you actually observed the changes that are happening at a physiological level when that novelty registers.
Exactly.
So memory is a good place to start. The older I get, the more interested I am in it, for reasons we're all familiar with, I guess.
Something interesting that emerged just recently at that point.
What's that?
Let me tell you something interesting that emerged just recently on that point, because I'm not getting any younger either. And that is, it turns out, and this is shown by a guy called Gerard Kasenki at Columbia, that bone is an endocrine gland, and it releases a hormone called osteocalcin. And it turns out that osteocalcin is quite effective in experimental animals in reversing age-related memory loss. So that suggests the interesting possibility that if we can increase the amount of osteocalcin that we release, we might be able to overcome or counteract certain aspects of age-related memory loss. And one way of doing that with experimental animals is by means of walking. So that would suggest that as people mature, walking should be a standard prototypic exercise for them. I love to swim, and there was a time when my laboratory was in a building right next to the student dormitory, which has a pool, and most days I would go swimming. I'm no longer in that building, so I don't have as free access to the pool, but even if I were, I would substitute walking for swimming, because I think the data suggests that at my age, that's probably a more beneficial exercise for me.
And that's because walking puts a kind of pressure on bones that leads them to release the hormone?
You got it. I don't know why you need me. You've got the whole thing worked out.
Well, I'm actually very interested because I swim. In fact, I have swum at the Columbia University pool. And what I do is swim during the day. What's that?
This is not the Columbia University
Right.
pool.
Yours was at a dormitory, it sounds like.
Very cool. That's right.
Yeah. But I swim during most days, but I take a walk at night, so I guess I'm covered.
Completely covered. You swim most days?
What's that?
You swim most days and you walk most days.
I walk at night. Yeah, I take a walk at night and
Wonderful.
listen to podcasts. Now this hasn't been documented in humans that it does increase memory, but you think there's actually very good reason or improve memory. But you think there's very good reason to believe that it would help.
Yes.
Okay. So memory is also a good subject with which to distinguish between problems that are pathologies, that are kind of diseases, and problems that are just natural problems. So memory naturally gets worse with age, but that's not the same as getting Alzheimer's, right?
No, not at all. There's a big difference between age-related memory loss and Alzheimer's. Alzheimer's produces certain anatomical changes in the brain that leads to the loss of nerve cells. And once you lose nerve cells, you cannot replace them. Age-related memory loss is a functional change, and it can be reversed.
Okay. And how much do we know about the mechanism? Well, in both cases, I guess, but in particular about Alzheimer's.
We know a fair amount about that. We know that there are plaques and tangles that form with Alzheimer's disease, and they lead to the loss of nerve cells. And the thing about loss of nerve cells is, unlike the loss of skin cells or other kinds of cells, nerve cells cannot be replaced. Mm-hmm. So once you lose certain nerve cells, you can't get them back. So with Alzheimer's disease, one of the reasons treatments are so difficult is because by the time you've diagnosed the disease, you've already lost a number of nerve cells, and one can't get them back.
Okay. Now, this business of nerve cells not regenerating, it seems like that's what I was taught growing up. But then about 30 years ago, there was some finding that bird brains could regenerate nerve cells. Am I imagining that? Was there some news about that seemed to reverse the conventional wisdom?
I'm not aware of it, but it's possible that this occurred. Yes.
Okay, but basically, I should not put any hope in that.
In mammals, particularly in higher mammals and humans, that does not occur. This doesn't indicate that other animals may not have that capability, as you say. But in mammals, and particularly in humans, it doesn't occur.
Okay. And that's why you need to catch Alzheimer's early, because it sounds like you can actually reverse some of the naturally occurring degradation of memory capability, but you can't reverse the kind that results from Alzheimer's.
You can prevent further nerve cell loss. Mm-hmm. You cannot recover what you've already lost.
Okay. So your book is about, as the title says, about unusual brains, including a number of what we would normally call pathologies, manic depressive, bipolar disorder, and so on. It's interesting. In some cases, it seems like when things go wrong with a brain, you can see that it's just kind of equipment that is natural, in a sense, kind of malfunctioning. So, for example, with mood swings, some degree of mood swing is presumably like built into us by natural selection. Sometimes it makes sense to be sad, conserve your resources, reflect on what you did wrong, whatever. Sometimes it makes sense to be exuberant. So with mood swings, that's a case where, right, the basic mechanism is a natural one, and it's a question of how it gets thrown out of whack, right?
Yeah, and it's a perfect description of it. That holds true for a number of things. Even when you come with severe depression, sadness is a part of life. In schizophrenia, the disorder is more severe, but even there's certain, degrees of freedom in thought that lead to creativity that we find as components of schizophrenia.
So that could be, in a sense, functional. But when you think about something like out-and-out hallucination, visual hallucination, it's not so clear to me, like, why would we be equipped with a natural ability to hallucinate? And in any event, if there's a logic behind that, why is it that most people don't do it, right?
Well, it depends on how rigorously you define hallucinations. When you sit there in the evening and you think thoughts to yourself, what are you doing? You're on the early steps to hallucinating, making up things. Part of a creative process involves allowing your mind to float freely in mental space, and that is on the way toward developing hallucinations.
So you see hallucinations as an extension of kind of imagination?
I think that's absolutely right. I think that a number of psychiatric disorders are abnormal extensions of normal processes.
And then are auditory hallucinations kind of an extension of the fact that our thoughts sometimes assume kind of verbal form, right? You know.
You have auditory hallucinations all the time when you hymn a particular song to yourself, or you conduct and sing to yourself parts of a symphony. You're hallucinating.
Yeah.
You're hearing the things in your head.
Or if you remember a social occasion when you said something and you're reliving it, or you're thinking, I should have said this.
That's it.
You know, it's funny, you mentioned John Nash in the book. Later we can get to maybe a little more into the connection between certain pathologies and creativity. But John Nash won the Nobel Prize in economics for his work in game theory. And he had, I guess, schizophrenia. Now, when I was, first of all, a story, when I was an undergraduate at Princeton, there was a guy who just hung out in the library, an older guy. And if you ask, who is that guy staring at me? They'd say, well, he's this mathematician who went crazy. And then 10, 15 years later, I opened the New York Times and there's a picture of him and he's won the Nobel Prize. And, but the interesting thing is, I once read that he said, you know, he had auditory hallucinations, I think, about that had to do with him having been sent here to create world government or something. He had all these elaborate ideas. And I think one time he said, well, the reason it made sense, the reason the voices made sense is because that's the way my ideas had always come to me.
Well, this is a person who used his psychotic disorder in a creative sense, and on occasions one might be able to do it. What really psychotic disorders do, it give you extra mental powers, if you will. Under the vast majority of circumstances, these are detrimental to happiness and orderly human behavior. But in certain circumstances, they might lead you along pathways of creativity.
Mm-hmm.
For example, manic depressive disorder is not uncommon among people with great creativity. Coming out of the depression into the mania is supposed to be exceedingly exhilarating. People feel empowered. They feel they have great strengths, creative strengths. They feel they have the great erotic strengths to become hypersexual in those phases, so that you can see how normal behavior might be enhanced in a variety of interesting ways in a manic depressive illness.
Although the question, I guess, arises like, I mean, if you wanted to, the trait to be kind of maximally adaptive, you just wouldn't have the depressive part, right? I mean, why not?
It was not designed to be maximally productive and creative. This is the nature of the disease. It turns out the disease has both beneficial and detrimental elements.
Right. So this gets back to what we're saying. Within certain range, mood swings are natural and adaptive, but then there's the pathological version. And you're just pointing out that even that may have some positive effects, but it's not designed to have that.
Perfect.
So now in the case of schizophrenia and a number of these things, we now know something about the genetic basis, right?
We know something, a modest amount, yes.
And is it, I mean, are there theories about like, there's a gene I think you mentioned in the book, correlated with schizophrenia, C4 or something. Is the thinking that it just kind of maybe showed up fairly recently in evolution and hasn't been strongly selected against, or is there even theory about that?
I'm sure there are theories about that, but I'm not sure that any of them have a great deal of support for it. One knows that there's a strong genetic basis for it, but that's the case for a large number of diseases. But certainly schizophrenia has been around for a very long time.
Okay. Now you mentioned some other creative people who, for example, Brian Wilson in the Beach Boys, right? Who I had actually always thought, I mean, I guess he was schizophrenic. I had thought maybe it was the LSD, but I guess maybe LSD can induce enduring schizophrenia.
It may have triggered a marginal condition, and that may wear off with time. And there are people who have transient episodes of schizophrenia, and then it remits. And it certainly holds true for manic depressive illness. It responds very well to lithium and other kinds of treatments. And that can be really reversed quite effectively.
And so what are some other examples of people whose we think of as creative, famously creative people, whose creativity may be connected to one pathology or another?
Kate Jameson, who's a manic depressive, is always attributing her creativity to this illness. She feels very fortunate she came in the hands of a very good psychiatrist with a combination of psychotherapy and antidepressant medication has helped her a great deal.
She wrote a book about this very thing, I think, right?
Several books about this, yes.
And I guess Jack Kerouac, I think you mentioned in the book, I actually hadn't realized he had any kind of particular disorder, but
he did.
So what about something like autism or I mean, do you think of that as being an extension of something natural? I mean, there is a spectrum, as they now say, and there are milder and more severe versions. But how does autism look to you?
Well, autism really affects what we're doing with each other now. We're involved in a conversation. But it is not just intellectual. There are emotional components or emotional overtones. These are compromised in a very severe way with autism. Autistic people have difficulty relating to one another. You and I, when we talk to one another, often look at each other's faces, look into each other's eyes. People with autism cannot look another person in the eyes. So there's a great deal of difficulty with just interpersonal contact.
Mm-hmm. But people with milder, people you would think of as having Asperger's syndrome and not being severely autistic, I guess are often very, very productive in certain realms, right?
Some Asperger people are quite creative, yes.
I guess maybe because that gives them the ability to focus or
whatever.
Yeah. So talk about can you talk about affect in kind of in general? It seems like a lot more attention is being paid. Well, let me say two things. It seems like a long time ago, people used to think of cognition and affect as almost two different systems. And then there has come to be, by affect, I mean, feeling, the basis of emotion. And it seems like there has come to be more understanding of how finely intertwined they are. Is that right?
Finding of what?
How finely intertwined affect and cognition are.
Well, all mental functions are intertwined, but it's perfectly legitimate to think of cognition, intellectual processes for solving problems, and affect, emotional interactions between people as having at least some significant distinctions and separateness.
Mm-hmm.
When you have people who have disturbances in affect, who are cognitively just fine, and you have people who have cognitive problems who are affectively quite fine. So in terms of just conventional biological ways of separating things that often come together, the separation is quite clear.
Mm-hmm. But I mean, for example, in memory, I gather it's true that the stronger the affect that's associated with an experience, the stronger the memory is going to be.
Sure, it means a lot to you. You hold on to it. Right.
Do we understand much about that mechanism yet? The mechanism that actually relates affect to memory?
Not really.
Mm-hmm.
We know the structures that are involved in that. Let's say, for example, the amygdala is importantly involved in affect, and hippocampus is importantly involved in memory, and they certainly communicate with one another. So you could see in principle how this would occur, but the details have not been worked out.
Okay. And can you talk a little bit about the amygdala? It's gotten a lot of publicity, it seems like, in the last 10 years.
Well, it's been around for a long time, and people have been aware that it's very important for emotion, and that it communicates with other regions of the brain and affects the modulation of emotion importantly.
Uh-huh. I mean, it's thought of as, like some kind of like warning system or something. I mean, it's triggered by very negative, fearful experiences, or,
but also by positive experiences.
Uh-huh. Okay, so it's not it's kind of neutral in that sense.
Yes, it's not exclusively from pleasant experiences.
Okay. And do you, one thing that comes through in your work is how well conserved over evolutionary time a lot of these things are, right? I mean, the basic mechanisms of learning and memory.
That's remarkable. I mean, this was a very good fortune of mine. So I wanted to be a psychoanalyst. And in my senior year of medical school, I decided even a psychoanalyst should know something about the brain. So I took an elective. We had a 6-month elective period in our senior year of medical school. And I took an elective on the brain, and I fell in love with it. And so after I finished medical school, my generation of people, physicians, were drafted for 2 years into the service. This was 1956. But those that were qualified could apply to the NIH, and if a laboratory was interested in recruiting them, they could substitute 2 years at the NIH instead of service. So I applied for that. I was selected. And Wade Marshall, who was head of my laboratory, was a hands-off guy, and he said, work on whatever you want. So I asked myself, if you're interested in psychoanalysis, what's the most interesting problem confronting humankind? And I thought, memory, and we have a beginning with memory. We know that the hippocampus is critically involved. So I had the simplistic idea that if I just record from cells in the hippocampus, I would understand how memory works. And I'd learned from an elective period that I took while I was still a medical student how to put electrodes into single cells. So I began to record from single cells of the cat hippocampus and recorded their activity very well. And I didn't learn a darn thing about memory storage. And I said to myself, aren't you silly? You're looking at one cell in a region. That's not how memory works. You've got to look at how regions relate to each other. You've got to use a simpler system, a reflex that can be modified by learning. So I began to take what is called a reductionist approach and looked around for a simpler animal in which one might be able to approach this in the context of learning and memory. And I looked for an animal that had few nerve cells, but nerve cells that were very large, so it would be very easy to record for them for long periods of time while you carry out a learning experiment. So I came across this marine snail, Aplysia, which has gigantic nerve cells. And there were 2 labs working on them. One was in Marseille and the other was in Paris. My wife is Parisian, and she said, going to Marseille is like going to Albany. So we obviously went to Paris. And I had a wonderful experience there, working in Aplysia. And I worked in Aplysia for the next 15-odd years. Defining a neural circuit that controls the behavior and seeing what happens when the animal learns something. And I found that what happens when an animal learns something is that the connections between nerve cells that make up the behavior become modified. With certain kinds of learning, the synapses become stronger. With other kinds of learning, they can become weaker. So, for example, if I scare the hell out of you by banging in the table, those connections get stronger. If I pat gently on the table, you would learn to ignore it. And what actually happens is, and the reason you ignore it, is that those connections get weaker. Moreover, a very interesting thing is one can see in the cellular level a difference between short-term memory and long-term memory. Short-term memory is a memory that lasts seconds to minutes and then years. Long-term memory is a memory that persists for long periods of time, days, weeks, the lifetime of an organism. Long-term memory differs from short-term memory, involving anatomical changes. There actually is a change in the way nerve cells communicate with each other. With certain kinds of learning, you get more connections. With other kinds of connections, get less other kinds of learning and memory. You get fewer connections. Moreover, these are due to alterations in gene expression. So long-term memory differs from short-term memory involving anatomical changes that result from alterations in gene expression. It's quite profound. So I was able to learn from these simple situations of beginning amount of the underlying biology of learning and memory.
What were the snails actually learning to do? What was the learning task?
Reflex behavior. They had an external respiratory organ called the gill. It's outside the body cavity. It was covered by a protective sheet called the mantle shelf that ended in a fleshy spot called the siphon. If you gave a weak tactile stimulus to the siphon, get a withdrawal of the gill, seeking protection underneath the mantle shelf. If you continued to give a weak stimulus, the animal would habituate. It would withdraw less and less. You can look at the neural circuit and you can see what happens, and you see that the connections between the sensory cells and the motor cells become progressively weaker, and after a while they stop responding. So even though you're stimulating, the animal doesn't respond. If you're not banging the table, the animal gets very scared, and a modulatory system gets recruited, and that strengthens the connections between the sensory nerves and the motor nerves. So you can take it as little reflex behavior, simple reflex behavior, and push it in both directions.
So learning to ignore the stimulus involved a reduction in the connections among cells.
That's right. So
but initially, the initial apprehension of the stimulus, or to take the other end, if the stimulus was really significant, if it turned out that every time they felt that was followed by something great or something horrible, like food or somebody smashing them or something, but not killing them, I guess, then you would get a strengthening you would get more connections among cells.
Yes, but after a while, even with positive stimuli, many of them, you get bored and you stop responding.
If with positive stimuli, so even if something good is coming, like the rat is pressing the bar and food is coming,
after a while it may habituate to it.
So once it's habitual, the increase in interconnection is for this kind of finite period of learning.
That's right.
And then once it's habituated, they don't need the connections, and I guess they spend their connections on something else.
Well, there's so many that's not a problem. But you're right. After a while, they stop responding because it's no longer of interest to them.
So then I assume that this is subsequently, this thing you documented in snails has been shown to obtain in higher organisms.
Yes, including humans.
Now, is this central to what you won the Nobel Prize for, this particular body of experimental work?
Yes.
My
work was the first that showed the cellular mechanisms whereby learning and memory occur. The learning involves changes in synaptic connections. The memory involves the persistence of those changes over time. In short term, it's a functional change, and long term, it's an anatomical change. So if you and I remember this conversation tomorrow, it's because our brains have actually altered to some degree. We've incorporated anatomically. These are modest changes in a huge brain like yours and mine. But these anatomical changes will persist for a certain period of time. Mm-hmm. We call them a day later, a week later, a year later, and sometimes a lifetime later.
And is the reason we forget so much? I mean, I'll give you an example. I've been doing these conversations for 13 years, and I've done more than one a week. And so it happens that a name will come up, and I'm like, sounds familiar. Anyway, there are cases where I'm not sure whether with a given person I've had a conversation.
It's normal.
Yeah, I'm glad. I'm reassured by that, and I'm wondering, is this fact of forgetting does mean, I guess, that there's some kind of finite resource in the brain? There's some reason that you're not hanging on to that and keeping access to it easy?
We can't understand the underlying plan of the nervous system, whether it's doing it for beneficial reasons, whether there are limits to what you can store, even though it would be desirable to store it longer. But the fact is, under most circumstances, you store information for a short period of time, unless it's either repeated or of great significance to you. You know, if you witness a scene in which something traumatic happens, something terrible happens, or something magnificent happens, you can remember that one experience for very long periods of time.
Mm-hmm. So you did this work in the 50s, this snail work, or the 60s?
In the 60s and 70s, yes.
So I guess it takes a while for the Nobel Committee to get around to giving you your due, huh? Or did this also, was the Nobel Prize also for subsequent work as well?
It was for some subsequent work. I moved from the snail to mice and was able to work on more complex animals and to show that the same kind of logic applies.
Mm-hmm. And what was it like winning a Nobel Prize? I mean, is it like you already kind of knew that you were one of the people who's likely to win one sooner or later, or was it more out of the blue, or what?
Well, it's neither out of the blue nor the certainty that you're going to get it. But you think that your work is important, and if your work is important, it should be considered by the Nobel Prize. But there's no way of knowing this.
Right.
They don't provide you with any clues whatsoever. And then one morning you get a call saying you've won the Nobel Prize.
And how did that feel?
Quite wonderful.
I assume it's a memory you've held on to.
Very much.
And then what, they fly you over to Sweden or something?
Yes.
And you're serenaded by these girls with candles in their hair?
That's not the high point of it.
Would be for me. But you gave a speech, right?
Yes, you give a speech, that is a high point.
Well, what was the theme of your speech?
I actually was able to do something which was very nice, and that is a friend of mine sent me a slide of an aplysia, which is the animal that I work on, with a Nobel Prize around its neck. And I showed that slide as one of my early slides, saying that aplysia is not only a very beautiful animal, but highly accomplished. Its accomplishments have been recognized. And there are many people who think that it's the snail rather than the investigator that should have gotten this award, the Nobel Prize. Obviously, people broke out in laughter. And you know how it is when you give a talk like this and you're nervous? As soon as you get the audience on your side of laughter, you relax and you can go on and give the talk that you would like to give.
It's interesting that you were nervous, because most people would think, well, if you're a Nobel laureate, I mean, you know, what's to be nervous about? But you were.
To the jury that gave you the Nobel Prize, so you want to make sure they continue to think that you're worthy of it.
Well, it's too late for them to take it back.
Well, that's not the point. You don't want them to feel they made a mistake, even if they can't take it back.
You'd rather, I guess. We've as long as we're talking about your career, why don't we go back earlier, much earlier? So, at some point, you had graduated from college and were interested in psychotherapy. But how did you?
No, you have to go back earlier.
Yeah.
I think what is interesting about my life, and I say this because I just came back from Vienna, is the fact that I was born in Vienna. And I got kicked out, or at least I left because I would have been killed.
This is what year did you leave?
Hitler marched in March of 38, and my brother and I left early. We left in April 39. My parents left in August 39. My parents left just before the war broke out.
Okay, so your parents, how old were you and your brother?
I was 9 and my brother was 14. We left on our own.
Your parents, well, you're with your parents' permission, I guess, but...
My parents took us to the train station because the boats don't leave from Vienna, and we went to Belgium, to Brussels. We caught a ship there, the SSS Geraldstein, and we took that to the United States.
And did you know anyone in the United States?
Yes.
You had relatives?
And my grandparents, who I knew in Vienna, had preceded us, and their son, our uncle, was in New York.
Now, they had been there for some time, or had they also left because of Hitler?
They had been there for 15, 20 years.
Okay.
He established himself, was quite comfortable in what he was doing, and he was able to provide the financial guarantee that you need to come to the United States. You need to have an affidavit. Somebody would say, the person that you're bringing over doesn't get a job, you will be able to support them for a certain period of time.
Mm-hmm. And so you wound up living in Brooklyn?
Yes.
What part?
I lived in Flatbush.
Brooklyn, that's where Ebbets Field was, right? Or
I'm not sure whether Ebbets Field.
It was on Flatbush Avenue, but Flatbush Avenue is a long avenue, not all of which is in Flatbush, I guess. So then how did you get from being an immigrant to going to Harvard? A presumably not affluent immigrant, although maybe I'm wrong, to going to Harvard.
Well, it was a very interesting and typical American experience. I originally went to a Hebrew parochial school, the Yeshiva of Flatbush, because when I first came over, I lived with my grandparents, whom I knew very well from Vienna, but they preceded us by about 6 months coming to the United States. So my brother and I lived with them. And my grandfather always thought that I didn't have an adequate Hebrew education. So he tutored me over the first summer I was there, and he had spoken to the head of the Hebrew parochial school, the Yeshiva of Flatbush, and they accepted me on a scholarship. So I went to the Yeshiva of Flatbush for 4 years, and when I graduated, I could speak English and Hebrew. I didn't speak Hebrew quite as well as I spoke English, but I could speak Hebrew quite well. And from that, I went to Erasmus Hall High School. In Erasmus Hall High School, in my senior year, my history teacher, Mr. Campana, asked me where I'm applying to college. And I said, I'm applying to Brooklyn College. My brother is going there. It's a very good school. And he said, did you ever think of Harvard? I said, no. He said, why don't you apply to Harvard? So I went home and discussed it with my parents. And they said, look, we put out $10 for Brooklyn College. It's a very good school. Your brother is going there. And I think that's fine. So I said this to Mr. Campana, and he said, here's $10. Apply to Harvard. So I applied to Harvard, and I got a scholarship to go to Harvard. And that was a fabulous experience. A typical American. This would not have happened in Vienna, I assure you.
No. I actually had a similar experience where my English teacher, when she asked me where I was going to college, and I told her, she was horrified. I mean, she had assumed I came from the kind of family where my parents would steer me toward an elite school. Right. We didn't have any clue. We just wanted to go where it was cheap and near. And so she was not pleased. Anyway, so you get to Harvard, and what did you major in?
History and literature.
So you were a humanities major.
I was a humanities major. I wanted to understand how people could listen to Haydn, Mozart, and Beethoven one day and beat up the Jews the next.
Really? That was the big question for you?
Yes.
The human capacity for greatness and evil.
So I wrote my honors dissertation on 3 German writers at different positions on the political spectrum. Zuckmayer, Karlse, and Jünger. Zuckmayer was a great liberal. Karlse was a person who was in between, and Jünger was a proto-Nazi.
Okay, and what did you conclude about?
That there were different positions in the political spectrum, and you could understand that Jünger was a very intelligent guy, but nonetheless, he was, an intellectual Nazi.
Do you have a view on, you probably remember Hannah Arendt and the phrase "the banality of evil," writing about the Eichmann trial and everything, and how people come to do monstrous things? Do you have a theory about that?
I don't have a particular theory, but people can do monstrous things.
This is true. So you graduated from Harvard as a humanities major, and so this makes sense. So you were interested in psychotherapy, which was, so this is what year you graduated from Harvard?
1952.
Okay. So
I, at that point, got to know a woman called Anna Chris, who's the daughter of parents, both of whom were psychoanalysts. Ernst Chris and Mariana Chris, very famous psychoanalysts. And through them, I got interested in analysis. So I thought that, maybe I would become an analyst. Well, to become an analyst, you have to go to medical school. You have to become a psychiatrist. And I had taken no science courses whatsoever. I was majoring in history and literature. So all of a sudden I had to add those science courses to my portfolio. And I did this by actually continuing after I graduated by going to summer school, taking my final courses. And I went to medical school with the idea of becoming a psychoanalyst. And then in my senior year in medical school, I thought even a psychoanalyst should know something about the brain. I took an elective in brain science and fell in love with it. I really enjoyed doing experiments, and that shifted me.
Okay. And so the rest is history. Now, you've talked about a kind of a new humanism or something, some kind of merging of the humanities and the hard sciences or something. Am I right about that?
Yes, I've written a little bit about this, reductionism in art and brain science, that the humanities and the sciences are not as far apart as many people think, that many artists are experimental and use strategies somewhat similar to scientists. And some scientists have a broad, humanistic, artistic approach to their work. So it's not a black and white issue.
Uh-huh. And are you yourself? Are you artistic? Is there a field of art you yourself pursue?
Only writing. I've written a number of books that are not directly related to my work.
Right. No, and you write very well. Did you, and very accessibly, did you, how did you come to that? I mean, there are a lot of scientists who are, there are some scientists who aren't great writers. Let's leave it at that.
Yes. I've always enjoyed writing. So when I was in high school, I was the sports editor of the Dutchman, which was the high school newspaper. And I wrote a column for a commercial newspaper called Gotham Sports. And my column was called Breaking the Tape with Eric Kandel, because I was co-captain of the Erasmus Hall track team. So I knew a lot about track, not only at the high school level, but college level and even beyond. And so I wrote a column for several years on this. So I was interested in writing.
Okay. Now, a lot is said these days about the role of genes in behavior and the functioning of the brain generally. Is it your sense that their role is overstated or understated or what?
Perfectly stated.
Perfectly stated by everyone?
Well, the genes are important, right? Yeah. Makes you who you are, makes me who I am. And it makes complete sense that genes can contribute to every aspect of our activity.
So I mean, do you feel like your temperament is mainly a function of the genes you were born with?
No, but the genes contribute to that. They provide the potential, maybe the limitations of them. Mm-hmm. And then these genes can, to some degree, be regulated by environmental experiences.
Uh-huh. And what, looking back on what has led to your achievement, what traits do you feel most grateful for?
Oh, I don't know. I'm curious.
Uh-huh.
And I like to learn new things. And I like to write. I get a great deal of pleasure out of writing.
Are you competitive?
Competitive? Not terrible. I mean, yes, I'm competitive, but doesn't affect my life very much.
So it wasn't a cutthroat quest to win the Nobel Prize that led to the Nobel Prize.
The Nobel Prize until I was very far along.
Uh-huh. Okay.
One doesn't go into science to win Nobel Prizes because the few who win compared to the many who contribute importantly is extraordinary. So there are many good people who don't get the Nobel Prize.
Yeah. No, there are. I mean, in general, intellectual progress is a extremely collaborative thing.
Yes, I benefited a great deal from my collaborators.
Mm-hmm. And I mean, the old standing on the shoulders of giants. Everyone inherits a body of knowledge that many people contributed to.
Absolutely.
So is there anything else you want to say about the book that broadly or specifically?
No, I enjoyed doing it. And I always learn a lot by, doing a new book. And, in this book, I really return to a theme that is intrinsic to psychiatry, and that is we learn a great deal about normal behavior by studying their exaggerated form in mental illness. And I sort of developed that theme in this book.
Yeah, will you hold the jacket up to the camera, because it's I think it's a really kind of a brilliant jacket, the way they, in a very subtle way,
it's done a very nice job.
Conveyed the theme. So you've got the one square that's kind of awry, right? I mean, it's the disordered part, and yet it somehow clarifies the order of the squares that are not awry.
Absolutely right. You're absolutely right.
It's brilliant.
They did a very good job with the cover. Yeah.
And then what are some of your other favorite books that people can buy?
I'll show you. So I've written 2 other books for the general audience. One is called In Search of Memory.
Right. Reasonably enough.
And this is really sort of an autobiographical book that explains, this is a picture of myself and my brother.
Ah.
And this is a picture of...
Which one are you? You're the smaller one.
I'm the smaller one.
Yeah.
And this is my father's toy store in Vienna.
So he owned a toy store in Vienna?
Yes.
And then what did he do in America?
He had a haberdashery store.
A hat store?
Haberdashery.
Doesn't that mean hats?
No.
No? What is a haberdasher?
Different kinds of clothing. So shirts, underwear, simple dresses, stuff like that.
No hats at all?
No hats at all. But other kinds
I've been confused all my life about what a haberdashery is, and
it may be a broad term. I may be too restrictive.
No, you're probably right.
My father's store, you could buy shirts, you could buy some ties, you could buy underwear, and you could buy simple dresses, and that's about it.
Okay. And then, did you bring a second book over there?
Yes. So that was my first book. My second book was a sort of an intellectual history from Vienna 1900 to the present of a theme in art. This is a Klimt painting, and I wrote about how Vienna gave rise to a certain strand of modernism in art and in thought.
Wow. That's a big book.
It is a very big book. It took a lot of work, yes. From Vienna 1900 to the present, that's a long period of time. The quest to understand the unconscious in art, mind, and brain.
Do you have a theory about why Vienna was so intellectually rich around that time? I mean, Sigmund Freud was there, right? All kinds of disciplines had a lot of ferment around then, right?
Yes. I was thinking about this today because I just came back from Vienna, and I've been asked to come back to give a lecture later in the year, the beginning of December. And I've been thinking about what I should give the lecture about, and I'm tempted to do it in a humorous way and speak about Wien, die Stadt ohne Juden, Vienna, the city without Jews. There was a novel written in 1924 that had that title, and what happened was that the leaders of the community in Vienna decided that the Jews were too prosperous, and the best thing to do was to get rid of them so that other people could prosper instead of them.
Now, this really happened, or this happened in that novel?
This is a novel.
Okay.
Okay. And so the
was it written by an anti-Semite or what?
No.
Okay.
And the city fathers got together and approached the leaders of the Jewish community and told them they've got a few weeks to move out, but they have to move out. And after they moved out, the theaters began to experience a decline in attendance. Movies had to close down altogether. A lot of those shops had a dramatic decrease in sales. Some of the attractive young women were saying, where were the guys that used to take us out all the time to the theater and to restaurants? So in a relatively short period of time, you would get onto the trolley and people would say, where were the good old days when the Jews were here? So the city fathers had no choice to do but to invite the Jews to come back.
So is this one way of saying that a big part of the intellectual ferment around the turn of the century was Jewish?
They contributed importantly to it.
Right.
They contributed to it because some of them were creative themselves, but I think in a more important way, they had rather advanced tastes, and they supported artists and writers who made Vienna what it was in 1900. It was really a tremendous outburst of creativity. Klim, Kutashka, and Sheila, fantastic artists, very good writers. And so they were supported in good part. At least
sorry, go ahead.
In part by the Jewish community.
Seems like there was in economics, there were some big names around then, although I don't remember any offhand, but it seems like that was a big field too.
An area I really know much about.
Have you read Karl Schorsky's thing
Yes.
about? You have.
Yes.
Turn of the century Vienna.
Yeah.
Okay, well, listen, thank you so much for taking the time. This has been a real pleasure. Thanks for all your work. I'm going to walk even more than I had been.
There you go.
So that I don't forget this conversation.
Good.
Which I don't think I'm in danger of doing anyway. But again, the book is The Disordered Mind, What Unusual Brains Tell Us About Ourselves. Great book, and thanks a lot for talking about it, Eric.
Thank you for having me on your program.